Now we consider applications. First, we consider chemical reaction. So carbon dioxide plus water can obtain oxygen plus glucose, so in this case. And for this equilibrium, you will find homogeneous linear system, right? So we get x1 equals 6x4, and 2x1 plus x2 equals 2x3 plus 6x4, and also 2x2 equals 12x4. Okay, so for this chemical reaction, in fact, in order to get equilibrium, you will solve homogeneous linear system. Okay, now we consider another application, electrical networks. So for this application, we want to determine the amount of current in each branch. So we have this one, and using this laws, Kirchhoff laws, at every node, the sum of the incoming currents equal the sum of the outgoing currents. So you will get, for example, at this point, okay, you get I1 minus I2 plus I3, I3 in this direction equals 0, okay? And if in this point, at this point, you will get the second equation here. Okay? These two equations, essentially, they are same, right? And around every closed loop, the algebraic sum of the voltage must equal the algebraic sum of the voltage drops. So, for example, in this loop, the voltage is 8. We have 8, so equals for voltage drops, you will get here is 4I1 here, right? 4I1 plus 2I2 equals 8 for this loop. And for this loop, you will get 2I2, so 2I2 here, plus 5I3. So I3 you will have, this is I3, right? This is I3, so 5I3 equals 9, because the voltage you have is 9 here. So using these equations, you can get linear system here. You write augmented form. Okay, and this is overdetermined system. However, this overdetermined system is consistent. You can have the solution. And now we consider the third application, economic models for exchange of goods. So we consider in primitive society, people use a bartering system. So there are three types of people: farmer, manufacturer, and people who making clothes. Okay. For farmers, they produce their goods, and 1/2 of their production they use themselves. Okay, and for farmers, they will send their 1/4 goods to manufacturer. See, here 1/2 they use themselves, and 1/4 here they give to 1/4 give to people who make clothes, and 1/4 they give to people who make tools, manufacturers. Okay, and similarly for manufacturer, 1/3 of their production they use by themselves, and 1/3 to the farmers, 1/3 to the manufacturers, 1/3 to the people who make clothes. And for people who make clothes, they use 1/4 for themselves, and 1/2 to farmers, 1/4 to the manufacturers. In the equilibrium state, we may have this model, Vasily-Leontief model, like this. Okay, so x1 is the value of the goods produced by farmers, and x2 is the value of the manufacturer's goods, and x3 is the value of clothing. So you will have x1 equals 1 over 2 times x1 plus 1 over 3 times x2 plus 1 over 2 times x3, and for x2, for the manufacturer, you will have this equation. This means the value they produce should equal the value they use, right? So we have this equation. And the third one, for the people who making clothes, they also have this equation. And after you solve this, you can get the value of different goods.